welcome to Adventure Story channel. Today, my dear friends, we will run through to auxiliary boilers advanced course. We will start and we will see all the aspects which is related with the boilers. In the end of this course, you'll be able to handle in advanced mode your auxiliary boilers, and you will better understand how the system works and what precautions you should take to avoid any problems and any dysfunctionalities. At the end, you will have a clear understanding, you'll be able to solve problems, and you will maximize the lifetime of your equipment without getting any problem, without interrupt the normal operation. Thank you that you're here, and let's quickly start because there is a lot of information waiting ahead. I hope that you will enjoy all the material that I have collected in the previous months, but now is the day that we will run through it. So let's start and let's see how our course will be distributed. First of all, we have a beautiful image on the right of our boiler in operation. Everything is good, everything seems that operates smoothly and nice. So from the first day, we will run through this part system. We will identify how the system works, how we can make some adjustments, how to rectify some problems, and what I have faced also with that. We will see how the tubes will be repaired. We will see the sequence of the boiler. We will see the feed filter tank and the performance curves. In the day 2, we will deep dive more in the feed pumps, the IGS, the C part itself, and blowdown procedures. On the day 3, we will talk about the ignition, the boiler damages, some cases of accidents, and the swiller adjustment. Day 4, it's master reset, MGO lock, and calibration. And we will get some running through the corrosion problem. In the day 5, important points, unisub, burners, differences, weak points of the system, diagrams, and boiler operation. I would like to share with you that I have both operate the Aalborg boilers and Mitsubishi boilers. I have identified both of them positive and negative things. But this is the crucial part when you are knowing your equipment, where your equipment is weak or where is some positive. And the operator should know that, so he will know the capabilities of his equipment. Let's move on. Let's start. Let's see the general description of the system, what things we have, what items and equipment is installed in the boiler, and let's run from all that equipment. Let's see. The first and the most important part is the safety of the boiler system. Without that, we cannot operate in the safe manner our system, and we cannot rely only on the operator. So there will be some things that will save us some additional appliances in case that operator will not notice that one, or another crucial thing will happen. So let's run from these points and see how important they are. First of all, when we are working with the boilers, we need to make a pressure work permit. Whatever we are doing, we must be identifying if our boiler are pressurized or not. So this is what the pressure work permit gives us. There is some checklist, and you're running through that checklist and you're checking all that stages. And at the end of that, after your identification, all of the problems and risks that associated with the pressure, you can make your job safely. But it's not always the case, and this is how we will fulfill this checklist. I will share with you that not all of the checklists can identify some potential hazards, because the checklist also was designed for the ideal conditions. But we will see it in forward. And I will share with you before we're going, because yes, it's better to share in this moment. Otherwise, we will forget it in the forward material. It's better to make it now. So, when, let's say for example, if the checklist tells you that you need to check here the pressure, and you have a pressure gauge somewhere here, you have checked and there is no indication on the pressure gauge. But are you sure that your pressure gauge indicates the proper pressure, or what you read there is proper? So you cannot rely only on one thing. And through the experience, you will see that you'll be able to identify if there is any pressure inside. So let's say, for example, we have the pressure gauge here. It shows 0. And on the checklist, also the question is that equipment pressure 0? You say yes, because you see the pressure gauge. But later on, when you open that one, there is some pressure present. So that means that your pressure gauge probably had a damage or a problem, or the instrument is not functioning properly. So there is another means for identifying. And what is that one? It's our drain. So what we are doing, we see the gauge, we open the drain, we leave the drain open, and we drain all that pressure. But if we open the drain, how we are able to know that everything is drained and our drain is not clogged or plugged or something else? We will see it from here, from the drainage funnel. So when we are opening the drain, we will see that the funnel, it's functioning, there is some steam coming. And at the beginning here, it's better to keep it closed, so you will not accidentally be sprayed with high temperature steam or liquid. If there is nothing running here, that means your drain is clogged. So what you will do? Again, you are not safe. But probably you will believe that there is not any pressure inside in the vessel, but there can be clogged of the drain. There can be clogged of the line here. So what the engineer should do, or the officer who is assigned, it can be also the deck officer or engine officer, or any of the operators that working in the terminals, on the factories. And there is another thing that you can do, because this system here, and that's which is really important, that the operator knows the system, knows how it connects. So this line here and this, they are going to the same space. And you have also probably here a gauge, you have also another drain. So you can drain it from here. So in case you have a clog here, you can drain it here and see if it functions again. So you have somehow a double check made already, and also you eliminate and you reduce with that way the risk. But the pressure work permit, which is here, will never says you that you need to do that. This will help you, your experience and the knowledge of knowing the system properly. So let's go to the risk assessment. The risk assessment is the next stage. You will identify all the hazards, and later on you will take a proper decision how you will move on your work. So by reducing the risks and lower it down, you'll be able to work safe. Another thing that you should do with your team, and that's how the people should work on board, and they should feel that they are a team. They are really a team that everybody can rely to each other, and in any case they can ask each other of, if I'm doing that one, what is your opinion? It will be good solution, or I have think already a plan. If we do that, what we can face and how we can do it better. So this is how a team works. And in all that thing, it's really, really necessary, because we have high temperatures, high pressures. We have also a lot of instrumentation. There can be also electrical cables associated. There can be some difficult locations also. All that items need to be identified and talk with the team. So that's why always, and the work that is associated with all that items and equipment, there is a teamwork which will think the plan, will make a plan, and later on do the operation of maintenance or some cleaning operation. And whatever equipment we are using must be appropriate. We will not use lamps which is in no good condition. We will not use material and PPEs which is not proper. So we're always looking for improvement in all the fields, and that's makes the overall safety high enough, so you will enjoy your work also, because you know that you are protected, you are safe, and your colleagues, they're always there to support you. Reduce the pressure to zero when you're making some cleaning, when you're making some maintenance, let's say some checkings, and do not rely always that somebody check it for you. You make also your checks, you make your also double checks before doing everything. So what is the next step to do is isolate the system, so you will not have a risk from other boiler which potentially can be under pressure. When we are working on one boiler here, and as we know, the boiler system is closely associated with the lines, and one boiler with another, there's some separation valves which will withstand the pressure and keep us a non-return valve, but not always rely that non-return valve is closed or it's operated properly. So when you depressurize one boiler and you have the other one pressurized, be sure that you have isolated the other boiler too, so you will not get any pressure running from one boiler to another as an emergency situation that can happen unpredictable. So what I'm meaning, if you depressurize this boiler here, there is some line at the bottom here which is the main line, and both boilers are connected, and only one non-return valve and the main steam valve will protect you from getting involved with the steam. So two valves only protects your life and you must be sure that they are locked and there is not any pressure. Be sure about that. Check always that they're working, because non-return valve can be also stuck and remain in one position. Also, these valves during the dry dock, it's necessary to inspect them to see that they are working properly. Examine all the piping in the system that can be interrupted from your activities. That means that you need to check some piping which is associated with your activities, how you will proceed, what you will remove, and how this will affect the overall operation of the vessel. And dealing with the boilers, we are talking about high temperatures, and even the boiler will be depressurized after 1 or 2 hours. The temperature and the heat still present here on the materials and the metal piping. So leave the boiler to cool down. Leave the boiler to cool down for 1-2 days, and later on proceed for the checks, and then slightly open the drains, check, isolate everything, open the vent valve here on the top, and look if everything is depressurized, cool down. As these boilers has a tremendous heat which is accumulated and heat balance inside, we are talking about thousands of kilojoules stored in this equipment. It's not a small equipment. It's really big. It's 40,000 kilograms per hour steam production. So we're talking about a big amount of water and steam. Always, before you enter the boiler, measure the atmosphere, and the people also that involved there should have a portable monitors that always monitoring the atmosphere inside. Always they make measurements and always make enclosed space entry permit. Because in the boilers there can be created some atmosphere from the fuels, from the injection of the fuels, and if we have also a burner which is does not operate properly, that means that the fuel will be dropped down, and this fuel can make, or the diesel can make, additional hazard to the atmosphere and create explosive atmosphere. Be careful that there is a lot of hot surfaces outside the boiler and inside the boiler, and always make a plan of evacuation and inform always one per person. One person always monitors outside, the person that is there is inside. The light that will be used must be closed type, and will have some specification that it is a intrinsic light, so it will not create any sparks in case that there is some gases presented. So let's see the next stage. So if we have, in case of emergency, water level gauges are really important. So if our system, if our level gauging system of the boiler has a problem and we cannot identify the proper level of the boiler, because it can be through the entrance of the air to the measuring system, so we will get a reading which is not appropriate. And what we are doing in that moment, we are going direct to the local boiler indication of water level indication, and we see the water level from there. That's why it's really important to keep the water gauges in good conditions, so we will be able to identify the proper water level of the boiler. And in case of emergency, we know exactly what is the boiler level, because if we make it high enough, if we make it more than it is, we will make damage to the system if we have some turbines working. So all the water will go through the system and probably will reach the turbine. So this is the overflow of the boiler. And if the water is too low inside the boiler, the thing that could happen is the structural damage of the water. Excuse me, because the tubes will be exposed to excessive heat and the tubes will be deformed. So in that cases, we also need to know that our shutdown systems are working properly, that the fuel will be shut down, and in case that it's not working or something goes wrong, it's better to shut down the boiler than waiting and look and identify what is going on, because we do not have a clear view of the boiler of what's going there. Let's run through the rules. Rule number 1, avoid to stress your boiler, as we described in the beginning, by adding cold water quickly or reduce the water level too low or too high, and try as much as possible to not put a big amount of water inside of the boiler and stress the material. Rule number 2 is keep all monitoring systems in good order, and that's I'm talking about. It's the system that monitors the level from the control, the automatic control system, and the indications which is transferred to the engine control room, and also the local gauges, the water level gauges. This is your last barrier to monitor the water level of the boiler. Rule number 3 is to test the safety valves and the alarms and trips frequently. So this is your last barrier for your safety. And this is what will save you from the overpressure, from the overheat, and will give you a sign that you will be able to identify that something goes wrong. It's really important. Do not rely that you are lucky, and don't try to play with your how much lucky you are, because there will be one moment that lucky really does not help at all. So be verified that your system works, that your alarms are working properly, everything, all the indications that are right, and try always to have them tested and verify that everything working properly. Do not rely that how much lucky you are, or that you will make your trip for 3 months or 5 months and you will not have any problem, and then you will disembark and the other crew will come. So I have seen that things happen on board. Some people really get on board for 4 months or 5 months. They do not test anything, and when the other crew comes and replace them, they will get a lot of problems. They will get a lot of damages. Some things will not working, and this is really unprofessional. The first thing that it's better to do, and I'm always talking about that people that involved in such operations and such equipment, they must always write down all the things and explain to their people. So when you hand over, you say exactly what is the problems, what we need to face, what we need to improve, and really, if you do not fix something, nothing goes wrong, but just inform the next crew that we have this problem and it needs to be solved. Give attention to that, because you need to be careful and be aware that this is ongoing and this is how we will fix that. Or it's necessary to be fixed. And always remember that you are working as a team. So let's move on to another material. Make blowdowns, bottom blowdowns, and scoom blowdowns. There is bottom blowdowns and top blowdowns. So each blowdown has its effect. So scum blowdown, which is the top, remove any surface impurities, and the bottom blowdown will remove heavy sediments and mud. This is the reason why we make that one. The top blowdown scoom will be performed when the boiler is running. So during the boiler run operation, there will be some steam generating, and all that impurities will be flying from the top of the surface to the scoom blowdown line, and then later on to overboard. This is how it performs. But for the bottom blowdown, you can have your boiler off and you make it for 20 or 30 seconds. But before you do that, open your lines, heat up the line slowly by slowly blowdowning the line, and then open it to the full. You can listen a noise from the line, make like that, when you're opening to the full. And this is how fast your water flows. The preheating of the line is just to verify that you will not stress the line and you will not make damage to the flanges or to the gaskets. That's why always we make it like that. We leave the steam flow to heat the lines, but it's not always the case. But with that solution and with that trick, you'll prevent a lot of problems to the lines and to the gaskets to be damaged. Another thing that is really important, that we can control our boilers both in local and the manual. This is applicable for all the boilers. Whatever boiler you have, all of them can be operated in the local and in the remote. And most of the boilers has also a emergency operation station or emergency operation control. It can be local, it can be in the panel. It depends the boiler design, depends the boiler size, and the communication between the panels and the local panel will be some cables. Here we have the common power section with motor starters also, and the cabling for these boilers and such applications has a specific length. So just have in your mind that whatever you change your cables and everything, you proper measure the length of the cable, because if the length of the cable will be changed, the signal also will be changed, and you will not receive the proper signal from the boiler to the control room, and the parameters will be changed and your boiler will operate differently. This is how the single boiler operation, and this is how when we have two boilers and one composite boiler also combined in the application. It's much better and much economically reliable to have a composite boiler like that. And in new vessels there is some design that there is a composite boiler, there is some generator gases passing there, and in the event in the port we have the use of that boiler. But in the big VLCCs, in the big tankers, and probably the Suezmax, there is one boiler, one auxiliary boiler running as a composite boiler, so you will have always steam in the port. It starts and stops because the demand it's not so high, but the reason that the boiler starts and stops because it's really big boiler. It increases the pressure to 10 kilograms or 9 kilograms, stops on, and then slowly the pressure will be reduced until 6.5 or 5.5, depends the settings you have set to the boiler, and then the boiler will start again and it will reach the pressure that you have set up. The times depends the weather conditions, the engine room temperature, and yes, the surrounding temperature. If the weather get colder, the boiler starts more frequently, and if you have also consumption to the deck, your boiler also starts frequently, and you need to see how you will keep the adjustments and the settings. It's better sometimes the boiler to run in slow mode if you have such consumption than stop and stop, because you will prevent your burner to get dirty from the start and the stop, and also your fans and all your equipment which is associated with the fuel supply will be running stable without a lot of adjustments up and down. But also the starting and stopping of the boiler, it's always a check of the system. So it will start from 0 to 15, let's say load, and in the beginning you will have the purging, and all your air fan will be operate from 0 to 70 to make the purging. So you will see also that your system are working, but your parts, your moving parts, slowly will be, let's say, used by the time, and you will see some mechanical failure problems, which can be associated with some moving parts, some rollers on the fan on the top, and some looseness on that. And this is how you adjust and you find a balance between how the settings will be and how often you will operate, what is the weather conditions of, let's say, that particular area, what is the heating conditions, because also the starting and the stopping of the boiler, it's not always the good case. And also, if you have cold conditions, it's better to adjust your engine room to fix your fan supply, so you will not cool down as much a lot, and also you can save fuel with that. There's a lot of parameters, and if you have any questions, you can always ask what is the best thing that we can do, so we will as much as possible eliminate the fuel consumption and increase the performance of the boiler, reduce the mechanical wear and all that stuff. So in this case, even we have some problem with the wire, we can still operate our boiler here. I really suggest you to make the operation of the boiler also from the local, to take the control there, so you will be familiar, and in any case, in any emergency, you are down there, you have your people that can operate, make some trainings. Additionally, when you have a big voyage, let's say, and you have time, you will be there with your people, sharing the experience, showing them how the emergency operation works and all that things. And that's all. As much as possible, yes, you need to operate the system and knowing how it works. In the event one boiler goes off, another boiler goes off, what we will do and how we will act. In each panel there is a program. So local panel 2, local panel 1, and contains the water level controller, oil and air controller, burner set points, and etc. Power panel 1 and 2 contain different things, and depending on the plant setup, some or all of the program is used. All panels, microprocessor units are talking to each other. Let's move on. Basic functions of the boiler: it's steam pressure controller, oil air flow controllers, atomizing steam controller, water level control, oil pressure ring line controller, oil temperature controller, alarm and shutdown functions. All that controllers are on the boiler. One boiler, low firing, maintenance, spray of pressure, modulation free, inner gas. Two boilers, we can run master or slave, slave rising, matching, modulation free, inner gas. This is some of the function of the boilers. Type of the boiler mostly used is the water tube type, as we have it on board. It's more efficient, water returns to the steam more quickly, long life, adapt better to the load changes, and gets less stress. This is how it looks like a composite boiler from inside. So the composite boiler, it's a different type. So here we have fill of water, and from the tubes inside passing the gases or the fire. This is called fire tube boiler. This is one of the dry docks that we have made. We drain all the water and make the inspection, washing. The tubes here, okay, they will not be as much as possible clear as metal, but they're in really good condition. This is how we look from the bottom to the top. Here there is steam generation on the top. The boiler water level is about here, as we can see, and here already the steam goes to the steam outlet. This is the main steam outlet valve of the composite boiler. So here, as you can see, the steam flows here, hit one plate there, and whatever water is accumulated is dropped back from this opening back again down. So as much as possible we get a clear steam in the lines without any water flowing, because in the lines we need a clear steam which will as much as possible transfer the heat to the tubes, and later on will start to condensate. After the heater, let's say for example for the purifiers, we heat our fuel to 98 degrees Celsius, the steam gives its heat, so it will enter 120, 130, later on give all the heat, transfer the heat, and our controller will be set up properly, so the amount of the steam that we supply, it will keep it 98 at the outlet. So the steam will be condensate, it will go to 98 and starts to go down, and already the steam condensate, it return back to the feed water tank. Can be condensed a little bit more, but it will return, yes, it will return slightly lower because there is a piping back again to the feed water tank, so it will enter about 60 or 70 degrees back again. Here we have the top of the tubes, so we are looking on this area on the top, and this is how the exhaust gases come out. You can see the sulfur here, the sulfur concentration on the top, and all the fuel and exhaust gases goes on the top here to the funnel. So any exhaust that is accumulated here and here, it's the main engine exhaust gas is passing, need to be washed, cleaned, so there will not be any back pressure created to the tubes. The biggest problem that we can face through our boilers that are working with the exhaust gases is the tube size that will be reduced through the accumulation of the carbon and any material which will be here. But as you can see here, everything is washed, and a good washed boiler, it's a boiler we have a lot of rust here. This is a good indication. Another very interesting thing is the main components and mountings. So what we have installed as components on the boiler. This can be safety valves which prevent the overpressure. We have a main steam valve from where the steam flows out. We have the bypass valves or warming valve through the main steam valve to heating the line. We have feed water valves which feeds our boiler with water. We have water level gauges, blowdown valve to blow down the water, air valve on the top to remove the air when for the first time we start the boiler or after the cleaning, the scum valve which will pick up all the scum from the surface of the boiler, which is all the dirty that accumulated there on the surface, the inspection hole, the inspection doors, the manholes, the access doors, the drain for the furnace, because there's also drain on the furnace, and also it's really important to be free, because when you are washing the furnace you do not like any water will be remain there. So make sure that the drain is free before you wash your boiler, because afterwards it will be much difficult to clean it. And how to clean it and how to wash it and how to prepare, it's directly to put a hose inside, to open the water and see if the drain is working. Heating coil valves also really important, and the heating coil to keep your boiler warm or preheated before the operation. So let's see a diagram and how many valves are contributing with our system here. The most complicated that I can say it's Aalborg, and here we have an Aalborg system. You can see how many three-way and two-way valves we have. We have a different line system, we have fuel line system and instrumental air that is applied for the functioning of all that valves. We have the diesel ignition line which will supply separately, and we have also the atomizing steam which will be introduced from here with the help of the atomizing air. For the boiler, for the beginning, we can use the atomizing air, and then when we have more steam, we can switch from the atomizing air to the atomizing steam. This is always the case when the atomizing steam is less than 5 bars and it's not enough, so we're using air. This is always the case. Always know your atomizing air valves, where it's located, because in some case, if you do not have atomizing steam, you will need to switch to the atomizing air to make your boiler work. So as you can see how many components are involved here, and how everything is monitored and work. You can see that we have a differential pressure transmitter also, which measures the air inlet pressure and the pressure in the furnace, and also sometimes it's really necessary to disconnect the line here and here before the transmitter and blow with the pressure air here inside, but not to the sensor, because you will damage the differential pressure transmitter. This is for the reason because you need to be verified that whatever you are receiving here, the pressure between two lines are accurate and are not plugged, because through the time, yes, you will have some such accumulations, and that's why if your reading will be wrong, your boiler also will operate and perform in different ranges. But it will work. It will have a not proper indication of what is going on, and then some problems can start with the burning process. So the first thing that you need to verify that everything is clear, that your boiler receives the proper information, your equipment also receives the proper information, you have the proper adjusted pressures here, the atomizing steam and instrument, you have the proper fuel pressure, you have the proper fuel temperature, the diesel, it's enough, and all your settings are in the range with the manufacturer. After you verify all that and you closely monitor by each day if something has changed, you can identify if there is any problem. These valves also are able to stack up also through the switch over some fuels. They can be stuck, so you can be there, you can check how they operate, you can see the symbols if the switch is okay. But in case that there is something that is not operated, you will get an alarm with the number of the valve. So directly you know that that valve is not working, is not performing, and you're going there to resolve it. Pressure gauge. Calibrate your pressure gauges in the frequent time. Some good companies, they have a really nice management system. They have the exact time for each calibration of the pressure gauges, so you'll be able to check them frequently. It can be 3 months, every 6 months, or once per year. The safety valves and SOLAS requires not less than 2 safety valves in case that one safety valve will not be performed, or sometimes it's really necessary to release the pressure if one safety valve is not enough or not performing properly. And this is how they looks like. Really important is that your safety valve are working, and here in this image also here you can see that the wire here, it's little bit not aligned. I have identified through the experience that also this wiring system must be properly maintained and properly set up on the ship, because it can be not non-functional. As you can see here, and as you identify how the angle of the wire is positioned here, it does not really help the operation of that safety valve. So in that case, if the operator will pull the wire here, all that lever will be in some case bended to that position, because this level here only operates up and down. So the positioning and how everything is set up must be checked, and that's why here why we check the operation of the safety valves from the safe distance to see if everything is proper and working. In this case, we get some damage to the bracket here, was bended because the positioning was not proper. So already we created one problem which was necessary to be replaced, and likely okay, we cannot say likely because somebody ordered that spare, we have it and we replace it. But anyway, we have identified that problem and resolve it by positioning the wire cable exactly on the middle, so it will be function up and down. Let's move on. Let's see also here, yes, if you like to dismantle, there's 2 studs here. It's long enough, so when you dismantle one and another side, it will pull up here and reduce the pressure of the spring. Let's see if we remove the safety valve. This is what we see. Here we have the valve which is seated down, and close and seal this surface. Let's see a little bit more how it looks like. The spring here, it's really big spring, and slightly one valve with another, they have some different settings. It can be half bar or 1 bar, first one open and the other open, with some slight difference, but all the information that you need, it's here on the label or in the manual itself. And this is how you can make some lapping, but if the surfaces are good, it's not necessary to make any lapping. Here you can see the pressure increase, and later on the valve operate. And we have some leakage here through the shaft, but all the steam, most of the capacity goes to the safe area and not so much affects the engine. And this is how the proper way must be designed a vessel which drives all that steam and all that heat far away. If we compare here, because this is the Aalborg and Hyundai built, and this is a Mitsubishi built ship where all the steam goes out to the engine room, as I have seen. Yes, we have some connection here, really also drive it somewhere far away to the safe line, but I will show you how that operate, and you can see that the steam really goes, some part of the steam goes also to the engine room. It's not so nice because it can trigger some fire alarms, and really it's not a good case and solution. So as much as possible and make the design so the steam will be lead to the safe area. And this is how it is inside, how the whole system are set. It can be overhauled, can be checked also the function that all the surfaces are good and operational. Normally it's not necessary to fix them or let's say to make some adjustment. Normally it's you make first the test and then you will set up in case that will, let's say, exceed or the set point is lower. You do not like your safety valve open lower than normally set up because you will lose steam and you will get also some disturbance to the operation. Because just imagine if you operate your boiler at 15 bar and it opens at 14 bar, you will get some steam out, and then you need to identify if there is any alarm ongoing, it's real, from where is that. You need to adjust the system again and put it back to the normal range. So for today we will finish with that. We will finish with the safety valve, and I believe for the reason it's good that we start like that. We will continue later on with the other appliances and run through the material. We are now at the page 34, and until we reach the 800 pages that is here, you'll be able to see a lot of things. Thank you and see you in the next lesson. Bye bye.